Hello, in this video you will solve quadratic functions and find the x-intercepts by taking the square roots. When do you use this method? There are two instances when you use this method. One of them is when you have the equation in vertex form, the one I just circled in blue, and the second one is when you have the equation in standard form but there is no bx term. The second one is also in vertex form, but most people don't identify it as such because it lacks the parentheses. If you put the parentheses, it will look something like this: a x minus 0 squared plus, and just to make it look exactly like vertex form, we could convert that c into the k. Most people will prefer to refer to it as in standard form, so we'll go with that. There are three steps in using this method. Step number one, isolate the square term. Number two, square root both sides. This yields a positive and a negative answer. And the last step is to solve for x. The problem is on the left. If you look, there's a section highlighted in purple. That's the square term. It's square because the exponent is a 2, and everything inside the parentheses is affected by that 2. That's why that's a square term. The 2 in the front is unaffected because it's outside the parentheses, so it's not part of the square term. Let's go with step number one. We're going to add 32 to both sides. After performing this operation, the square term is still not by itself because there's a 2 in the front. Therefore, we have to divide by 2 both sides. Now we have the square term by itself. We move on to step 2. We're going to square root both sides. The reason for rooting both sides is to get rid of the radical and the exponent since they're opposites of each other. And this gives us x minus 2 equals, then we have to take the square of 16, which is plus or minus 4. Then, since we have a plus or minus, we have to break up the problem into two parts. This is part of solving for x. We start with x minus 2. That one remains the same on both problems. And on one side, it's going to be equal to the positive 4, and on the other one, it's going to be equal to the negative 4. That's where the 2 come in. Then you would solve each problem separately for x. On the left, we add 2 to both sides, and this gives us x equals 6. On the right, we also add 2 to both sides, but the answer will not be the same as the one on the left, or simply making it negative 6 would also be incorrect. We actually have to perform the